10C, regression method for individuals. Number 1, in a certain class, midterm scores average out to 60 with an SD of 15, as do scores on the final. The correlation between the midterm scores and the final scores is about 0.5. The scatter diagram is football shaped. Predict the final score of students whose midterm score. Didn't we just do this one? Okay, so you know how to do A. 1 SD right would be 1 SD up times 0.5. And then 2 SDs left would be 2 SDs down. Yeah. It's just a review, I guess. So D is unknown. So if we have no idea what a student scored, what's our best guess? The average. All right, 2. For the first year students at a certain university, the correlation between SAT scores and first year GPA was 0.6. What does that tell us about SAT scores and GPA? It's not very correlated. It's weak correlation, but it does have some. And as SAT scores get larger, GPAs get larger because it's a positive slope. Okay. Predict the percentile rank of the first year GPA for a student whose percentile rank was 90. So we have the 90th percentile, which includes all of this. So I have a 10% tail on either side. So the middle is 80%. I go to A104. I look up 0.8, and the z-score is 1.3. Okay. So this person is to the right 1.3 SDs of the average for the X. So right here is X bar, and right here is Y bar. But we don't know what those numbers are, correct? But if I go right 1.3 SDXs, I'm going to go up 0.6 of 1.3 SDYs, which is 0.78. So instead of going up 1.3, we're going to cut it off at 0.78. So my z-score for y is 0.78. This is my z-score for x. Okay, so 0.78 is a z-score for the y values. What do I need to do? No, it's not a percentage. My original student, well, it might translate into that, but that's not where the number comes from. So this student right here is in the 90th percentile for SAT score. And they had a z-score of x, which is 1.3. Their z-score for y is 0.78, which is going to be right here, 0.78. So we look 0.78 up in A104. And is it 79%? Yeah. So, let me look at A104. Sorry. Okay, here we are. And 0.78. What does the book say? Predict the percentile rank Um, I I think did they mess that up? Let's let's look again. What page are you on? A62. Okay. Yeah, 0.8, that's what we got. Oh, I know what we did wrong. We didn't do anything wrong. So here's the problem. Our z-score is 0.78, right? But that is a middle area. Okay, so everybody watch this. We didn't do anything wrong, we just weren't finished. We ended up with 0.78, and that's a middle area of, we have to round it to 0.8. So that middle area for 0.8 is 57.63. But we also need to include this. Right. So 100 minus 57.63 divided by 2. Add that back to 57.6. And that's where they get 78.8%. Okay. Now, let me show you that again. Right. Let me show you that whole problem again and see if you guys can understand that. So, well, should we just do the next one? Okay, 30%. 30% would be right there. Okay? Well, if there's 30 here and 30 there, how much is there in the middle? 40. I go to A104 and I look up the area of 0.4, which gives me a z-score of negative 0.55. Right? Because we're on the left. Okay? And we want to know what their score is, their GPA percentile rank would be. So what we have here is my point of averages, and I'm going to go left 0.55 SDs, which means I'm going to go down 0.55 SDs times my R is 0.6. So I cut this off at 60%. 0.55 times 0.6 tells me I'm going to go down 1/3 of an SD, right? So this is my X percentile, and this is my Y percentile. So the average is 0, and I'm going to go to the right or to the left 0.33. Okay, and when I go left 0.33, what is the area? Go to A104. 0.33. So, okay, if we round to 0.35, this is 27%. But that's not what I want. I want this. So 100 minus 27. That will give me how much are in the two tails. And divide that by 2. This piece would be 13%. No, not in this case, because we're on the left tail. Yeah. If you're below half, you don't need to add it back. 38? Did we get the wrong numbers? Okay, I didn't look it up in the table. Let me look it up. So, 40% is 0.55. Good. Then we take 0.55 and we times it by 0.6. And we get 0.33, so 27.37. Oh, I did 1 minus 27. Sorry, guys. 100 minus 27. Divide that by 2. I I typed in the wrong number. There we go. 37. Okay, 50%. If you get 50, if you're in the 50th percentile for SAT scores, where will you be for GPA? 50th percent, because we have 0 SDs, and 0 times 0.6 is 0. Okay, and then unknown, same thing, would be 50. Okay, number 3. The scatter diagram below shows the scores on the midterm and a final in a certain course. 3 lines are drawn. People who have the same percentile rank on both tests are plotted on one of these lines. Which one and why? Which one shows people that have the same X as Y? The dashed lines. Okay. One of the lines would be useful to predict final scores from midterm scores. And the regression line would be which of those 3 lines? The solid line. That's the one. I think that is, yeah, I think the dotted one is cutting the rows into equal. Okay, 4, the scatter diagram below shows ages of husbands and wives in Tennessee. Why are there no dots lower in the lower left-hand corner of the diagram? Right. It's not a height issue. No, sorry, it's not a, there's no height here. It's a marriage age issue. Nobody gets married below, according to this, below 19 in Tennessee. Which is surprising, right? We thought it would be 12 or 13. Why does the diagram show vertical and horizontal stripes? Why are all of those dots evenly spaced apart? We rounded age, right? Age should be a continuous variable, but we usually report age as though it's a discrete variable, right? But truly age, right? You have a decimal age that's always changing. Every instant it changes. It's always changing. That would be continuous, but we usually report age as discrete.